Hello everyone. Today we are going to talk about section 8.5, which is actually going to look at quadrilaterals that are not parallelograms. So what I did with this first slide is I tried to remind us of a lot of the things that we have been working on in chapter 8 with quadrilaterals. So I would encourage you right now to pause the video and read through the information about what we know about quadrilaterals, about what we know about parallelograms, what types of parallelograms we have, rectangle, rhombus, and then also squares. Then when you're finished kind of absorbing all of it, start the video back up and we'll look at quadrilaterals that are not parallelograms. So in section 8.5, we're going to talk about trapezoids and kites. A trapezoid has exactly one pair of parallel sides. So here are your parallel sides. Okay, if it had two pairs of parallel sides, then it would be called a parallelogram and we would not refer to it as a trapezoid. So keep that in mind, and as we go through this lesson, there is a blank lesson posted. You can pause, go to that right now, fill in some information with me, or you can be pausing and taking paper notes just so that you can keep all of these things straight. Nothing is really that difficult here, but it's just trying to remember which properties go with which quadrilateral, which ones are parallelograms, and which properties apply then, etc. So when we talk about trapezoids, they're really not that interesting. They don't have a ton of properties unless we start talking about isosceles. So in an isosceles trapezoid, okay, if the legs of a trapezoid are congruent, then we call it an isosceles trapezoid. Well, what are the legs? Well, the legs are connected to the two bases. Okay, so we call these parallel sides, okay, in an isosceles trapezoid, the bases. The legs, okay, are what connect the bases. So these are the legs. Okay, so just knowing that the parallel sides are the bases and the non-parallel sides are the legs. So what are the properties of isosceles trapezoids? Well, it's kind of like an isosceles triangle. So a trapezoid will be isosceles if and only if the base angles are congruent. So we talked about that the legs have to be congruent in order for it to be called an isosceles trapezoid. And here we're saying, hey, it's going to be an isosceles trapezoid also if and only if the base angles are congruent. So again, remember, these are our bases. And this is similar to what we learned with isosceles triangles. If we had an isosceles triangle, this was our base, and we had the legs were congruent. And we also knew that the base angles were congruent. Okay, so if these are the legs right here that we're talking about, then the sides opposite those legs, just like this, the side opposite those legs were congruent. Excuse me, not the sides, the angles. So these angles opposite the congruent legs will be also congruent. So a trapezoid is isosceles if and only if the base angles are congruent. So if you spin this and now this top piece right here, okay, is your base. Now you have, again, you have these legs, but you also have these base angles congruent. And one other thing about isosceles trapezoids here is that a trapezoid is isosceles if and only if the diagonals are congruent. So here is a diagonal and here is a diagonal. Okay, so it will always be true if your trapezoid is isosceles that side AC or diagonal AC will be congruent to BD. And remember, these are if and only if. So if I tell you that this trapezoid is isosceles, then you know the diagonals are congruent. Or if I show you a trapezoid and you can see that the diagonals, or you're given that diagonals are congruent, then you can go ahead and say it's isosceles. So remember, not all the pieces are always going to be marked. So use these if and only if statements to gain other information, which would also tell you now that these sides will be congruent. It would also tell you now, because you've determined that's an isosceles trapezoid, that this angle and this angle will be congruent, and this angle right here and this angle right here will also be congruent. So the next thing we talk about here is midsegments. Okay, so we define a midsegment of any trapezoid right here. It's kind of like the midsegment of a triangle. Okay, it is formed by the midpoints of each side. So the midsegment of any trapezoid is going to be parallel to each base, and its length is the average of the two bases, which you might kind of already expect. So we have all of these are parallel, and we have some information here that the midsegment EF is going to be the average. So we add up side AD and BC and then divide by 2. That's how we take the average of things. So let's look at a few examples. There's not a lot to this. It's just going to be working through some examples to apply these properties of midsegments and trapezoid. So this particular example tells you that ABCD is a trapezoid. Well, if it's a trapezoid, then you know that it has to have exactly one pair of parallel sides. It also tells you that EF is the midsegment. So because it told you that piece of information, you also know that this piece, BE and EA, will be congruent, and CF and FD will be congruent. Did not tell you necessarily that it was isosceles. It just told you that it was a trapezoid. So now it says to find the measure of AD. So what we're trying to find here is we're trying to find this side. Well, we know that this midsegment EF, okay, is going to be the average of 8 plus, we'll call this side X right now, divided by 2. So we know that EF is 14. So 14 has to be the average of 8 plus some number divided by 2. So now all we do is we go ahead and solve. Okay, it's not that difficult. We're going to multiply each side by 2. That's going to give us 8 plus X is equal to 28. Now we're going to subtract 8 from each side, and we're going to get X equals 20. So we found that AD, oops, not B, AD equals 20 units. Okay, so if you take 20 and 8 and add them together and you divide by 2, you get 28 divided by 2, you get your 14. So this is how we're going to use some of these properties to find some, of course, missing sides and angles. Here again, it tells you that ABCD is a trapezoid. So what that's telling you is that these two sides are parallel. Find the measure of the remaining angles. Well, what they should also give you, otherwise you really can't solve this, is you need to, well, no, not necessarily. I take that back, because we need to determine if this is an isosceles, because if it is, then we know that this angle right here will be congruent to this angle right here. Well, because these base angles right here are congruent, then we know that these legs are congruent, because remember that was an if and only if. So now because of that, what we can determine is that this is an isosceles, so we know that these will also now be congruent. So we know this is a quadrilateral, so the sum of all the interior angles will be 360. So now we know that 360 is equal to 51 times 2 plus 2 times like angle B. Or if we multiply this together, 51 times 2 is 104, plus 2 times, like angle B, will give us 360. So now, when I subtract 104 from 360, that gives me 258, which is equal to 2 times the measure of angle B. So now I divide by 2, and I get the measure of angle B is equal to 129. So B is 129 degrees, and since these are congruent, this is also the measure of angle B, or excuse me, angle C is also 129. Okay, last question here. I plotted these coordinates for us already. It says, given the coordinates, show that ORST is a trapezoid. Well, if it's a trapezoid, it needs to have one pair of parallel sides. So what I need to show is that RS is parallel to OT, or I need to show that RO is parallel to ST, but I don't think that's going to be the case just from looking at it. But what I still should do always is show that then RO is not parallel. So it's not parallel to the other side, which would be ST. I know that seems obvious, but you should still do it just for clarity. Now, how do we show the lines are parallel? How do I show that RS is parallel to OT? Well, I show the slopes are the same. So I need to show the slopes are the same. And vice versa, I need to show the other slopes are not. So what I'm going to do here is I'm going to find the slope of RS, and I'm going to find the slope of OT. So again, we take the ordered pairs for R right here and S right here, and we use y2 minus y1 over x2 minus x1, the slope formula. So I get 4 minus 3 over 2 minus 0, which gives us a slope of 1/2. The slope of OT right here, so O and T, again, is y2 minus y1, so 2 minus 0 over x2 minus x1, 4 minus 0, which is 2/4, which is equal to 1/2. So, since the slopes are the same, I can now show that RS is parallel to OT. And again, just for the sake of argument and making sure, because we really wouldn't have to graph this to show it, now we're going to find the slope of RO and find the slope of ST and show that they're not the same. So again, with R and O, I'm going to take 3 minus 0 over 0 minus 0, and I'm going to get 3 over 0, which is undefined. And the slope of ST, again, y2 minus y1, so 2 minus 4 over 4 minus 2, which gives me negative 2 over positive 2, which is negative 1. So slopes are not the same. So that means that RO is not parallel to OT. So try some of the problems from the homework. Okay, I have a couple summary slides that you could pause, one on isosceles triangle or trapezoids, and now we're going to move into kites. So a kite is a quadrilateral with two pairs of consecutive sides that are congruent, but opposite sides are not. So this means consecutive, next to each other. Okay, so those two sides are consecutive and congruent, and these two sides. That's by definition of kite. The opposite sides, so when we look at these two sides, these are not congruent. That's what that means. Okay, so there's a couple properties of kites. So a quadrilateral is a kite. If a quadrilateral is a kite, then we know that diagonals are perpendicular. So what that's telling us is that this diagonal and this diagonal are perpendicular, so all of these angles will be right angles. And it also, if we have a kite, then one pair of opposite angles are congruent, and it's the angles that are between the non-congruent sides. Okay, so what that means is the non-congruent sides. So these are the non-congruent sides, so it's the angle between them. So it's these angles right there. So just to mark that maybe a little bit better, it would be this angle and this angle. Okay, so here's a summary again of kites. And again, I would pause the video and just kind of try to read and decipher. And then we'll go through just an example or two. So it says solve for x. Well, I can tell this is a kite because I have these two consecutive sides congruent, and I have these two consecutive sides congruent. So because of that, what I know is that there's one pair of opposite angles between this non-congruent sides. So that would be this angle right here and this angle right here are congruent. Well, again, knowing that the quadrilateral has to have a sum of interior angles equal to 360, so I know 360 is equal to 124 plus 80 plus 2x, because this is x also. So then 360, if I subtract 124 and 80 from that, what I would get is that I would get 156 equals 2 times x, divide by 2, and each of those angles is 78 degrees. Here we're told that this is a kite. Well, because we're told that, then we know that these two sides, consecutive sides, are congruent, and these two consecutive sides are congruent. We also know, remember, that the diagonals are perpendicular and one pair of opposite angles, that's already marked congruent. So we have a lot of information. We're supposed to solve for x, y, and z. Well, it's pretty obvious that we're just going to set x plus 2 equal to 3x minus 6. And if we go through the steps of solving, it's a pretty simple solve because we end up with 8 is equal to 2x, or x equals 4. So there's one of the things we found. So now let's work on solving for y. Well, we already found that x equals 4. Whoops. So what we know is that this side is 14. So we know y then is equal to the same, and that is going to be 14. So how do we find z? How do we find this piece? Well, notice we have a right triangle, and we already know that from x equaling 4, then this side is 4 plus 2, so this side is equal to 6. So we can use the Pythagorean theorem to solve because we know 3 squared plus z squared is equal to 6 squared. So now we can have z squared is equal to 36 minus 9, which is going to give us 25. So take the square root of each side, and z is equal to 5. So now we found x, y, and z. All right, well, good luck. Take advantage of my office hours. Again, read the section. These are the problems you're going to try. Again, you can take the book electronically and copy and paste into Notability, or just do it on paper and submit that way. Have a great day, everyone.